They shine in the night sky, those distant, serene points of light we call stars. But stars are so much more than just twinkling decorations in the cosmic dark. They are the universe's grand alchemical furnaces, the crucibles where matter is forged and energy unleashed on scales that dwarf our everyday comprehension. From colossal exploding giants to the invisible remnants that warp space-time, stars are cosmic powerhouses. Tonight let's explore 10 mind-blowing facts about stars that will illuminate your understanding of the cosmos. When you gaze up at the night sky, you might perceive the stars as mostly uniform, perhaps tiny pinpricks of white light. But the reality is far more vibrant, a veritable rainbow scattered across the cosmic canvas. Stars come in a dazzling array of colors, direct indicators of a star's surface temperature. The hottest stars blaze with an intense blue or blue-white light, while cooler stars glow red. So the next time you look up, remember you're seeing a spectrum of stellar temperatures, a colorful broadcast from space. We often speak of the sun and the stars as if they are entirely different categories of celestial objects. But here's a fundamental truth. Our sun is a star, specifically a G-type main sequence star or yellow dwarf. It's not the biggest, brightest, or hottest star out there, but its proximity makes it special to us. It's a humble reminder that we orbit a rather ordinary star, yet one that makes our extraordinary existence possible. Stars, like all things in the universe, have life cycles. For the most massive stars, death is a cataclysmic event, a supernova explosion. When these giants exhaust their nuclear fuel, gravity wins the final battle, causing the core to collapse and rebound in a titanic shockwave. This explosion, the supernova, is one of the most energetic events in the universe, outshining entire galaxies. These explosions scatter heavy elements across space, elements that will form new stars, planets, and perhaps new life. When we picture a star, we often imagine a solitary object like our sun. However, most stars are not loners. A significant fraction, perhaps more than half of all stars in the Milky Way, exist in binary or multiple star systems. These binary star systems are cosmic dances, with stars locked in gravitational embraces. Their interactions can lead to fascinating phenomena like mass transfer between the stars, or even influencing their ultimate fates. We've talked about supernovae, the explosive deaths of massive stars. But what happens to the core remnant of such a star if it's particularly hefty? If the leftover core is more than about 3 times the mass of our sun, gravity's triumph is absolute. It will crush itself down, beyond any conceivable density, resulting in a black hole. This is a region of space-time where gravity is so strong that nothing, not even light, can escape its grasp. Not all stars end their lives in the fiery spectacle of a supernova or the mysterious abyss of a black hole. Stars like our sun face a different demise, becoming white dwarfs. These stellar remnants pack an immense amount of matter into a small volume. A typical white dwarf might contain a mass comparable to that of our sun, yet it's compressed into a sphere roughly the size of the Earth. This results in an almost unimaginable density, with a teaspoonful of white dwarf material weighing several tons on Earth. We tend to think of our sun as enormous, but in the grand cosmic zoo of stars, our sun is far from being a giant. There are stars out there, hypergiants and supergiants, that are so colossally vast, they make our sun look like a mere speck of dust. Consider UY Scuti, a red hypergiant with a radius more than 1,700 times that of our sun. If you were to replace our sun with UY Scuti, its surface would extend far beyond the orbit of Jupiter. These are the true titans of the universe, luminous behemoths that challenge our very sense of scale. We've explored the explosive deaths of massive stars and the colossal sizes of supergiants. Now, let's turn our attention to the smallest, faintest stars, known as red dwarfs. These diminutive stars possess incredible longevity, burning through their hydrogen fuel at an incredibly slow rate. While a star like our sun will live for about 10 billion years, a red dwarf can continue fusing hydrogen for trillions of years. They are the true Methuselahs of the cosmos. This next fact brings the grandeur of the cosmos directly into your own being. Every single atom that makes up your body, with the exception of hydrogen and some helium, was forged in the heart of a star. When massive stars explode as supernovae, they scatter these newly created elements across the galaxy. These elements then mix with interstellar gas and dust clouds, forming new stars and planetary systems. In a very literal sense, you are made of stardust, carrying within you the legacy of ancient stars. For millennia, humanity has looked to the stars for guidance. The predictable patterns of the constellations and the steadfast presence of stars like Polaris served as celestial maps for ancient mariners and desert travelers. Stars were our first cosmic signposts, helping us to understand our place on Earth and to explore its far reaches. This role continues into the modern era of astronomy and space exploration. From ancient voyages to future interstellar journeys, stars remain our indispensable guides through the immensity of space and time. So, there you have it, 10 glimpses into the astonishing nature of stars. From their vibrant colors to their cataclysmic deaths, stars are the engines of cosmic evolution. They remind us of the vastness of space and time, but also of our intimate link to the cosmos. Every atom in your body forged in a stellar crucible tells a story that began billions of years ago. Keep looking up, keep questioning, and keep marveling at the stellar tapestry above.